right. This video is going to be talking about bonds. Chemical bonds. Hopefully some of you have seen James Bond, otherwise that is just completely over everybody's head, which is fair. It was a bad joke anyway. All right, so anyway, chemical bonds are the strong attractive force that exists between atoms. And this is going to be this is going to be recapping what we've learned and extending on what we learned in the last unit. I harped on valence electrons a ton because I was like, that's all we're going to talk about in this unit. Because that's the whole point of bonding. All right, or it's not the whole point, but that's what's involved when bonds form. The valence electrons are involved. So understanding how to find valence electrons are important. What are valence electrons, you ask? It's like, oh my gosh. If you don't get this by now, every assignment we did, I was like, hey, how do you figure out valence electrons? What are valence electrons? I feel like I hit that pretty hard. So if you still don't know, just leave. I'm just kidding, don't leave. But it is once again, it's the outer level electrons. All right, and you can determine how many valence electrons an element has by the group it's in. All right, and there's two ways bonds can form. All right, one of that is known as ionic bonds. All right, ionic bonds occur by the transferring of electrons. All right, so I think this is a vocab term I introduced last time, but we're going to get into it more. An ion is created. So an ion is so we talked about isotopes are when there's more or less neutrons. It's atoms of the same element with more or less neutrons. Ions are when it's atoms of the same element, but it has a different number of electrons. All right, so it has either a positive or negative charge. All right, and so if it loses an electron, it becomes positively charged. You might be like, well, that doesn't make sense. But it does, because if it loses an electron, it's losing a negative charge. So it now has, like in this case, the sodium atom has 11 protons. When it loses that electron, when it's neutral, it has 11 electrons. But when that electron leaves, now it has 11 positive charges and 10 negative charges. So it's going to have a positive charge because it'll have one more positive charge than negative. And then when the chlorine takes it, it will now have a negative charge. And what happens in an ionic bond is those opposite charges attract. All right, so that positively charged ion that is created will attract to the negatively charged ion. All right, so those opposite charges attract. So they become, that's why it's called an ionic bond. They become ions and then they bond. An ionic bond. So it helps to know what an ion is because they become ions first. And then the other way is a covalent bond. A covalent bond is when there's a sharing of electrons. So here's an example of like hydrogen and oxygen. Now oxygen is going to take it more, and this isn't a complete picture, but you'll see that the hydrogen will also share to have its first level filled. All right, where they'll share electrons in order to have a full outer shell. And then they're basically fighting over those electrons. We say it's sharing, but they're basically trying to fight to have a fight over those electrons. And so that's known as a covalent bonding. And we're going to talk more detail about each of these. All right, with that word co, if I co-own a business with you, I share ownership. All right, and when compounds form, a new compound is completely different than the individual elements that make them up. We talked about this with at the beginning of the semester with compounds. When we talked about elements and compounds, we said it's very different. Like sodium is a cuttable metal. You can cut it with a knife. It's very brittle, highly reactive. Chlorine, poisonous gas. All right, when those two things react, though, they exchange just one electron, just like what we did in the last example. One electron goes from here to here. A whole new substance is created. All right, this is created, table salt. All right, and so you have sodium chloride. So you have table salt, very different than the individual elements that make them up. All right, these two things are very different than this. All right, because a new substance is created. It's a chemical reaction that's occurring. All right, so chemical bonds are written as chemical formulas. Chemical formulas include the elemental symbol for the elements involved and the number of atoms involved in the formula. So a lot of you guys probably know the example of H2O. You probably are familiar with that. Like that's water. Yeah, H2O. You probably don't even know what it means when you've said it. What that means is that water is comprised of two hydrogen atoms. That 2 goes to the H, and 1 oxygen atom bonded together. All right. And so that subscript will tell you the number of atoms involved. And you might say, well, that number, The oxygen didn't have a subscript. There's no subscript there. If there's no subscript, it'd just be like writing a 1. All right, it's kind of like in math. You don't write like, when you're writing like x plus 2, you don't write 1x plus 2 because it's implied that the 1 is already there. All right, so if you're, just think of it like math, like x plus 2, you don't write 1x plus 2. All right, it's not wrong if you do, but it's just not something you need to do because we wrote an O there already. All right, so you don't have to write a 1 there. Clearly, it's involved in the formula. You don't have to write a 1. It's just needless. All right. And so one of the things we're going to get into, because this is going to be really helpful for the next unit, is to talk about how to count atoms. All right, so we're going to be balancing chemical equations next. And so we have to understand how to count atoms. The best way to do that, so if we take sand, this is where it helps, by the way, to know the names of things. One time I was looking at a recipe, or not a recipe, it was taco seasoning at the store. And I was like, oh, I wonder what's in this. I looked and it said silicon dioxide is in it. I was like, that's sand. Gross. So we just make our own now. But yeah, super gross. They just call it silicon dioxide. And nobody knows any better. They're like, oh, okay, yeah, I'll eat that. Nasty. Anyway, so what helps is just to write out each element. Remember, each element is characterized by a capital letter and then sometimes followed by a lowercase letter. That's one element. So even if there's no subscript there, so if I said how many total elements make up silicon dioxide, you would say 3 because there's one, or not elements, how many atoms are in a unit of silicon dioxide? 1 silicon for every 2 oxygen atoms. Now this is a simplified formula. This is the ratio that exists, but it's not like there's just 1 and 2. There's trillions of these, but this shows the basic form of the ratio. All right. For cane sugar, if I said how many carbon are there, you'd say 12. Hydrogen, 22. Oxygen, 11. All right, so you would write out each of these. So if I ask you questions like how many, and even if sometimes they're in like different spots like this, all right, so you'd have 3, and then 1 over here, you'd have 4. All right, and the reason why they write them in different spots is just because the chain of the molecules is different. So just showing the way they're bonded. This hydrogen's not bonded necessarily to that, but so that's why it's written in a separate spot. But 2 carbon, we've got carbon in 2 different spots. So there's a 1 here and a 1 here. So 2 carbon, 4 hydrogen, 3 plus 1 is 4, and 2 oxygen. Sulfuric acid, this oftentimes gets missed if you don't write out each capital letter when you're doing this. Because if you don't write out each capital letter, now I did this for you, but if I didn't, a lot of times people just say, oh, 2 plus 4, there's 6 atoms there. It's like there's not 6 atoms there. All right, there are 2 plus 1 plus 4. This question will be on the test. This gets missed more, and it's the most basic question just because people are too lazy. They don't write out each capital letter. So I did it for you. Make sure you do that on the test. Now, sometimes you'll see it where there's a parenthesis. It's just like math. You got to distribute this 2, or I don't even know if that's the right word for it. So Mg is not in the parentheses, so we don't take that 2 to the Mg, but we would take this 2 to the O, which since there's a subscript 1, it'd be 2 oxygen and 2 hydrogen. 2 times 1 is 2 hydrogen. So you multiply this number by what is on the inside of the parentheses. If this was a 2, you'd multiply 2 times 2. There'd be 4 oxygen. All right, but since it's just 1, it would be 2 times 1, 2 times 1. All right, so why though? Why do elements form bonds? All right, the whole point of bonding is to reach stability. What is atomic stability? It's a full outer shell of electrons. All right, so full outer shell. That's the whole point. We want to get to that full outer shell. What's a full outer shell, you ask? The octet rule is what we're going to follow. Most atoms form a bond in order to have 8 octopus, octagon, 8-sided shape, 8 electrons in their outer shell. That's the whole goal. This is the whole point behind bonding, is to have a full outer shell of electrons. That's the whole point. All right, and so these noble gases over here, these all have a full outer shell of electrons. So this is what makes them kind of unique, is they used to be called inert gases. They don't bond well. We talked about these in the last unit. They don't form bonds because they already have that full outer shell. So they don't readily bond with other elements. Essentially, all the elements on the periodic table want to be like these uniquely stable noble gases. Now, you might even say the noble gases are the cool guys of the periodic table. All right, and I'm going to refer to them as that. All right, so atoms will gain, lose, or share electrons, not just because they want to, but the whole point is to have a full outer shell of electrons to become stable. You might say, well, that's weird because sodium is losing its electron. It doesn't have any now in its outer shell. not so fast, my friend. We have, if sodium loses that 1 electron, that next level you can see is 1, 2, 3, 4, 5, 6, 7, 8. It's got 8 in its outer shell. Chlorine has 8 in its outer shell. They become oppositely charged and they attract. They bond. So now each side has a full outer shell and they attract to each other. All right. And so that's the driving force behind there. Oxygen or water, it's the same concept, but with sharing. So hydrogen shares one of oxygen's electrons. Another hydrogen shares one of its electrons with oxygen. So now oxygen has 8. Hydrogen, remember, hydrogen only has 2. You might say, I thought the octet rule. Remember, the octet rule applies. Most energy levels are considered full with 8. We talked about this a little bit in the last unit. We said helium's stupid for being in this noble gases group, because remember that first level, that first energy level is filled with 2. That's the only level that does not obey the octet rule. That first energy level is just filled with just 2 electrons. All right. So regardless of if the electrons are gained, lost, or shared, the end result is a chemical bond, and a chemical bond is the force that holds the atom together in a compound. And the whole point of chemical bonding is to reach atomic stability, to have a full outer level of electrons. And that's usually 8, except for that first level, which is considered full with just 2.